Ever stop and think about how your phone just seems to get you? When you talk to it, when you type in a search, how does it have any clue what you actually mean? Well, today we're pulling back the curtain on the incredible technology that makes all of that magic happen.
I mean, think about something as simple as this. A phrase you might say every single day. You tell your smart speaker, "Alexa, I like this song," and bam, instantly it understands and acts on it. Now, that's not just some clever programming trick. It's a field of artificial intelligence that is completely changing how we interact with the world.
So what's the secret? How does your phone make sense of our messy, emotional, and often really complex human language? Let's dive in.
That simple command to Alexa is a perfect window into a world called natural language processing, or NLP for short. And really, it's all about one big idea: teaching computers to understand and use language the same way we do.
And trust me, this isn't just about voice assistants. NLP is the powerhouse humming away behind the scenes in so many tools you use constantly. When Google finishes your search query for you, or when your email throws a message into the spam folder, or even when a document suggests a better way to phrase a sentence. Yep, that's all NLP doing the heavy lifting.
So let's get down to it. What is this powerful technology really? At its heart, you can think of natural language processing as a kind of super important bridge connecting our world of human communication to the cold, hard logic of computers.
Okay, so the official textbook definition is that it's a specialized branch of AI focused entirely on language. But what that really means is that the ultimate goal is to give machines the power to not just scan our words, but to actually figure out our meaning and understand our intent.
To really get where NLP fits in, it helps to zoom out and look at the whole AI family tree. Right at the top, you have artificial intelligence, which is this huge overarching idea of making machines smart. A big piece of that is machine learning, which is all about getting machines to learn from data instead of being explicitly programmed. And then as a specialty within that, you have NLP, which focuses specifically on learning from language.
Now, NLP itself kinda has two main jobs, two sides of the same coin. First, there's natural language understanding, or NLU. Think of this as the input, the reading and listening part, where the machine tries to figure out what's being said. And on the other side, you've got natural language generation, or NLG. That's the output, the writing and speaking part, where the machine creates a response that actually sounds like a human.
Okay, so how on earth does a machine actually learn to do all this? Honestly, the best way to wrap your head around it is to imagine we're putting a computer through a special kind of school, a series of language lessons designed to teach it how to read.
And this school has a 5-part curriculum, where each lesson builds directly on the one before it. We start super basic, just identifying individual words. Then we teach it grammar. After that, what the words literally mean. Then, how different sentences connect to each other. And finally, we get to the hardest lesson, the final boss of language, understanding the unspoken intent behind what we say.
So, lesson 1 is lexical analysis, and its most important job is something called tokenization. All this really means is the machine learns to stop seeing a sentence as one big jumble of characters. Instead, it has to learn to break it down into its individual building blocks, these little pieces we call tokens. It's basically the digital version of learning to see individual words on a page.
And here's what that looks like in action. You take a simple sentence, and boom, it gets chopped up into word tokens, including the punctuation. But what's really clever about modern systems is they can take a complex word like unbelievably and break it down into its meaningful parts. This is a total game changer because it helps the machine handle new words it's never seen before.
Part of this first lesson is also about simplifying. I mean, a machine needs to know that run, running, and ran all point to the same core idea, right? Stemming is the quick and dirty way to do this. It just chops off the word endings. But a much smarter method is lamitation. It's like using a dictionary to find the actual root word, so it knows that the root of was is actually be.
Okay, so our computer can now spot individual words. Great, but understanding how they all fit together, that's where things get really tricky. Take a look at this classic sentence. Who has the telescope? Are you using it to look at the man, or is the man the one holding it? This problem right here is called ambiguity, and it's one of the single biggest challenges in all of NLP.
This is exactly where Lesson 2, syntactic analysis, grammar, becomes so important. By analyzing the structure of the sentence, the machine can actually map out both of these possible interpretations. It's like drawing a diagram of how the words could logically connect.
But to figure out which one is correct, well, for that, it needs to understand meaning, which brings us to the next lessons.
And now, for the final and maybe the most advanced lesson of all, pragmatic analysis. When someone asks, "Can you pass the salt?" are they actually questioning your physical ability to do it? Of course not. They're asking you to pass it. This is all about understanding social context, subtext, and what is meant, not just what is said. This is the final frontier for a machine to truly understand us.
So after our machine graduates from its language lessons, what can it actually do? Let's take a look at how this all comes together out in the real world.
The applications are already vast, and they're just exploding. I mean, think about the last time you used a customer service chatbot that actually solved your problem, or translated a foreign website with a single click. In finance, it's used to analyze market news for investment signals. In healthcare, it's pulling vital information from millions of patient records. The impact is just enormous.
Let's zoom in on one particularly powerful application, sentiment analysis. A company can use NLP to scan thousands of product reviews and social media comments to get an instant pulse check on public opinion. So they can see here that 65% of the chatter is positive, which is great. But the real gold is that 20% that's negative. For a business, that's not just a number, it's actionable intelligence that can help them fix a problem before it gets out of control.
Now, as incredible as NLP is today, the journey is far from over. This field is advancing at a breathtaking pace, but there are still some major hurdles to clear.
The technology still isn't perfect. Nuances like sarcasm and really deep context are still incredibly difficult for machines to pick up on. Training these massive models also requires an immense amount of computing power, which is very expensive. Plus, there's a huge data gap for less common languages, creating a kind of digital divide. And finally, there's the black box problem. A lot of the time, we don't know exactly why a model made the decision it did.
But the future is incredibly exciting. We're seeing the rise of these massive foundation models that have an unprecedented grasp of language. The next great leap is what's called multimodal AI, systems that can understand text, images, and audio all at the same time. Just imagine an AI that not only reads a negative review, but also sees the photo of the broken product the user posted with it. That's where we're headed.
So from simple commands to complex conversations, NLP is the bridge that connects us to our machines. And as this bridge becomes stronger and more sophisticated, it forces us to ask a pretty profound question. When our technology can understand us as well as another human can, how will that fundamentally change our relationship with it?